Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 14 of the subject of Object-Oriented Analysis and Design, in which we will study the state machine diagram of the UML. Dear students, in the state machine diagram we have multiple states and every state represents particular functionality. Now, in every object which is associated with a class, there are set of the functionalities, that is the data members and the member functions. The member function provides some useful information to the user. Now, in every state diagram there are multiple states, so that's why there is a great resemblance between the class diagram and state diagram in terms of the functionalities. So we can represent the functionality in terms of the state machine diagrams. So that's why this topic is very much important for object-oriented analysis and design. This is the discussion agenda. It contains the topics of state machine diagram, uses of the state machine diagram, difference between state diagram and the flow chart, basic components of the state diagram, steps to draw a state diagram, examples of the state machine diagram. Now, what is the state machine diagram? Basically, every state machine diagram has a behavior or the behavior which provides the functionalities, or the discrete behavior or the part of the design of the system. The state machine diagrams can be represented through the finite state transitions. The state machine diagram is also used to express the usage protocol of the part of the system. The usage protocol means that how the system can be used for the particular services. Now there are two types of the state machine diagram which is defined in the UML 2.4 standard. Number one is called behavior state diagram and the second one is called protocol state machine diagram. The behavior state machine diagram is a subclass by a protocol state machine diagram. That means that protocol state machine diagram has a child called the behavior state machine diagram. In the behavior state machine diagram, we have the behavior of the system, while in the protocol state machine diagram, we have multiple packages and these packages acts as the protocol. Now, where we can use the state chart or the state machine diagram? When we want to use the states, the event responsible for changing in the state of the system. For example, if an event rises, then certain operations are performed. Then the state machine is used here. So here we want to use a certain events. Here processes are not used because processes are used in the simple flowchart diagram. When we want to model the dynamic behavior of the system, here the dynamic behavior means the runtime response of the system. When the system is running or it is executing, then what sort of the functionalities will be provided by the system, that is called dynamic behavior of the system. To understand the reaction of the object classes to internal or external stimuli. The internal or external stimuli means that certain events that rises internal to the software or external to the software. The internal stimuli are those events which rises inside of the software. For example, if it is that the timer is executing and after 5 seconds certain events arises, then this is the internal stimuli. While the external stimuli is that event which rises or which occurs external to the software or a product. For example, if there is the external camera and the camera takes a picture or record a certain events, then particular external stimuli will occur. For example, if there is the movement and the camera is detecting the particular movement, then the camera provides input to the system and then system performs certain operation, that is called external stimuli. Now, what is the difference between the state diagram and the flow chart? The basic purpose of the state diagram is to portray various changes in the state of a class and not to represent the processes or commands which causes these changes. So in the state diagram, we only provide certain states. We do not provide any sort of the processes or commands. Second difference is that in the flow charts provides us processes or commands are of execution, while in the state diagram we provide only particular set of the behaviors. Now, what are different components of the state diagrams? There are multiple components of the state diagram. First one is called initial state. Initial states means that it is the start state or the initial or the first state of the state machine diagram. We use here the black filled circle represents the initial state of the system or of the class. Next one is the transition. How we represent the transition in the state machine diagram? We use the solid arrows to represent the transition. Transition means, for example, one state is transited into the another state, then the transitions will occur. So here the transition means that the control from one state to another state, and this is represented through the arrow line labeled with the event, which causes to change the state. So event is the particular event here that in fact it is causing that the state is changing. So why we want to go to state 2 from the state 1? Because of this event. Next one is simple states. In the state, we represent the rectangle to show a state. A state represents the condition or circumstances of the objects of a class at an instance of the time. So when this states, it shows this states is in fact it is showing the particular sort of the condition or circumstances that why a particular event is rising, or when the event occurs, then this state is executing, which provides a certain behavior. Next one is called fork. Fork means that when a state is executed, then after this two or more than two parallel states can be also executed. So then we provide a round solid rectangle bar which represents a fork notation with the incoming arrows from the parent states and outgoing arrows towards the newly created states. We use the fork notation to represent the state splitting into two or more concurrent states. So these are two and more concurrent states which are splitted. Next one is called joining. The joining is opposite of the fork. So here a round solid rectangle is used to join the states. So for example, here two different states are executed, then the output of these states are joining towards the one single states. So incoming arrows from the joining states and outgoing arrows towards the common goal states. We use the joining notation when two or more states are concurrently converged into one on the occurrence of an event or the events of the state transition diagram. So this is called the joining states. Next one is called self transition. Self transition is the same as like when a loop is a particular function is calling itself. So here we use a solid arrow lines pointing back to the states itself to represent a self transition. There might be a scenarios when the state of the object doesn't change upon the concurrence of an event. Then when the particular events occur, then the states cannot be changed and the same states will be called again. So we use a self transition to represent such cases. Exactly, it is like the recursion. When a function is called, when a function calls itself. Next one is called composite states. Composite states occurs inside of the state machine diagram, which is a sub-state machine diagram. We use here a round rectangle represents a composite states. We represent a state with the internal activities using the composite state diagram. And the last one is the final states. Final state is used as a filled circle within a circle notation. This is a circle notation, and inside of it is a filled circle, and it represents the final states of the state machine diagram. That means that it is the exit states. That means again, as like the start state, it is called the finishing or the closed or exit states. Now, how we will draw a state diagram? First of all, we need to identify the initial states and the final terminating states of the state transition diagram. Next, then after identifying the initial and the final termination, we identify the possible another states in which the object can exist, and we will define the boundaries values corresponding to different attributes guides us in identifying different states. So here in these steps we will identify all other states of the state machine diagram, and then at the end we will label the events which trigger these transitions. At the end we will label all the arrow lines when a particular transition occurs. Now we will here explain different sort of the examples of the state machine diagram. For example, this is the start states. After start states, when the card is swiped, waiting for the pin, and after pin waiting, then the pin is inserted and the pin is verified. The pin code is verified, then the user is identified. So this is a state machine diagram which represents the verification of the pin code of our credit card. First of all, it is the start states, then card swaps. Card swaps is the condition. Then a state is called waiting for the pin. Waiting for the pin means that the system will wait for the pin from the user. Then when the user enters the pin code, then the verification states will be called. And if the verification is unsuccessful, means that the pin code is wrong, then the pin code is rejected, and again the system will wait for the pin. And if the user provides us valid pin code, then the pin verification states will be called. And after valid verification, then the user will be identified, and this will be the terminations of the user state machine diagram. This is another example of the state machine diagram for the online ordering. First of all, this is our start states, order received, and then it will be placed into unprocessed order states. And after that, if the order is rejected and the order is checked, then the order is rejected. Maybe different reasons. For example, if the items are not available or the amount in the credit card is insufficient for buying this particular orders, then the terminations condition are the final states will be called. And if it is checked and the order is accepted, that means accepted order, then there will be two different states may be called. So some items not available to be processed or some item available to process deliver. So if some items are not available for the processing or they are not available in the stock room, then the pending order will be called. And if they are all available, then the order will be fulfilled, and then the state machine diagram will be exited. So this is the state machine diagram for the online order. This is another state machine diagram of the cooling system. For example, if we have a cooling system and the cooling system is in the idle states, first it is the start and then it is the idle states, and then after idle the cooling states will be called. So if it is too hot is the event and desired temperature is passed in the too hot functions, then the cooling states will be called. And after the cooling states, then if it is too cold, the room becomes too cold, then the heating states will be called. And the heating state is the sub transition diagram. Here it is the starts and then activating and then it is active, and that is the subset of the sub transition diagram. And if it is too much heating, then again it may go into the ideal states, or if it is too hot, then it again can go into the cooling state, and this will be executed in the loop. And if the user want to shut down, then the shutdown states will be called, which is the final states. This is another example of the state machine diagram for signal sending. So first of all, we will that is the system will be in the idle after start states, and then after start states there may be, if there is a noise, so it will search it. The searching state will be called, and if it is target 8p is thread t.add.target.p is called, then the tracking states will be called. Tracking means it tracks the particular signal, so then the tracking system is called. And after then the engaging states will be called if it provides good context, and after engaging the system will be terminated. Now if there is certain noise after searching, then the tracking states will be called, and after tracking the engaging states will be called here. This is very much advanced state transition diagram. You can see here that there are multiple states, and this is in fact a threading system where different states will be called. Dear student, this is the end of the lecture. If you have any question, you can ask your question through the email. My email is m.kadim@kust.edu.pk. I have taken all these informations from these two books. You can study these two books for your further information, and if you have any query, you can email me. Thank you very much.